So fasten your seatbelt because in this video, we're going to do a deep dive into the advanced options screen. I'm going to begin by extracting the images contained in an SER file. If you're not familiar with these files, SER files are like zip files in that they contain hundreds of images. Programs like SharpCap, FireCapture, Nina, QHY cameras, and others can be configured to create SER files. To start, I'll click on Tools and then select Export from SER File. To save us time, I've already put the name of the input file here. I selected it earlier with the ellipsis, and I set the output file for the extracted files to a folder named Subs. So now I'll click Export. We've just exported 443 frames to the Subs folder. Now I'll use this convenient button that both opens the stacking window and moves to that folder name. Here we can see the FITS files we just exported from the SER file. Now, just like we saw in an earlier video, I can click on this button to explore the folder. There are all of our FITS files. Next, we need to go through these sub-images and find a good image to use as our reference image. I went through this data earlier, so I know where I'm headed. I'll start by double-clicking on image 39 to open it. I'll zoom in on the profile graph with my mouse wheel. Let's look for a good feature on the profile graph. If we can't see any features in the profile, we could use the zero-order star itself. So I'll set this image 39 aside as the best image I've seen so far, since it's the only image I've seen so far. I'll move it to the reference profile by clicking on the Set Reference button. And then I'll use the scaling window to move it a bit vertically. So now I can step through the images on the grid one by one by using Control-N and Control-P to move backwards and forwards. Here's image 40. This new one in red looks better than the one in blue. So let's set that aside by clicking on the reference button again. What about the next one? Well, image 41, I guess that looks deeper and better. And look how sharp and narrow that hydrogen beta line is too. So I'll grab this one. Now the next image, 42, that red one is way worse than the blue one I set aside, so I won't grab it. And the next? This time, let's use the Open Next button just to remind you about the buttons themselves. No, that's worse than the blue profile too. I'll keep doing this until the red profile line is the best I can find. And hey, don't worry if you don't get the absolutely best image. The stack will be good regardless. All this does is lets us see on the plot screen which images aren't very good so we can discard them. Oh, that's the best yet. A nice, smooth, symmetrical, deep hydrogen beta absorption line. Let's stop here and use that as our reference image. So again, I'll click on the Set Reference Image button to select it. So now I'm going to open the Stacking Options window. And then I'll move to the Advanced Options tab. And just to make sure things are how I want them when I start, I'll click on the Reset to Defaults button. One of the key things a stacking engine does is align or register the images by sliding them left and right and up and down until the star in the image is in the same location as your reference image. To understand how this works, let's see what happens when we don't align the images. I'm going to remove the check marks from this box. This will show us what happens when we don't align the images. And by the way, you'll see that word register when using other astro imaging tools. We'll use the words register and align interchangeably here. Okay, now we're finally ready to stack, so I'll click on the Stack button. A message popped up here that says, please draw a red capture box around the ROI before processing. Oops, I forgot to draw my red capture box. Let's do that now. I find it easier to draw it in the zoom window. So let's open the zoom window with the toolbar button. Now I'll hover my mouse over the star and use the roller wheel to zoom in on the star. Oh, that's a really blurry and distorted star. Atmospheric seeing wasn't very good on the night this was captured. And of course, remember that the proper focus on the spectrum means that the star won't be exactly focused. It won't be pinpoint. But this one is really messy. By the way, see video 50 for more information on all of this. Okay, well, let's draw our red capture box. I'll hold down the control key, then hold down the left mouse button and drag my mouse. Okay, there's our red capture box. I drew it with a little bit of margin around the star. See this link here? Links like these in the log window are clickable. They open the FAQ with further information about this message. This one simply explains what the message means and how to fix it. We're not going to read the whole thing now. Let's close the window. Oh, and one more thing. I don't know about you, but I prefer larger fonts on lengthy text. So let's enlarge this font. I'll click on the gear and run it up to 13 or so. Ah, that's much easier to read. Okay, now for goodness sake, let's get on with it. I'll click the stack button and wait until it's done. Okay, so we just stacked 443 images. And I didn't speed up that playback just now. You just saw the real-time stacking speed on these moderately sized 5 megapixels images. Oh wow, look how much the zero order star drifted because we turned off image registration. This much movement means that our tracking mount probably didn't do as good a job as it could. On each successive image, the star drifted a few pixels, first to the right, and then after a while, up, and then back a little bit to the left. Remember, we told RSpec not to align or register these images. So the stacking engine combines all of these images together to make a stacked output file, and so all of these stars appear smeared across this track. And let's look at the stacked spectrum in the image by double-clicking on the zoom window to zoom out, and then using my roller wheel to zoom in on the spectrum. What a mess this is too. As the star moved, it created multiple spectra here, all smeared together. Let's turn on the histogram stretch. This particular spectrum is the brightest because the star was moving to the right the entire time, so each one overlaid the other and made it bright. But because of that movement, the absorption features were all covered up by subsequent spectra. But in these other spectra, you can even see the absorption features, and you can see them moving as the star moved up and then to the left. You can call these ghost spectra or shadow spectra. When you see them in a stacking result, it means that RSpec had trouble finding your zero order or that your target star drifted out of the red capture box. And just as a reminder, it did that in this stacking run because we turned off the registration and then our telescope drifted a long way off target. And if we look at the profile on the graphing screen, we can see the red profile has virtually no clearly discernible features at all because the moving star smeared the result. And look, even the zero order of the star moved a long way from where it was on the blue curve of the reference star. That would probably throw off any calibration efforts we might try later. So that's what I wanted to show you in this first portion of the video. I wanted you to understand what image registration means. In day-to-day use, we usually won't see this kind of smearing because RSpec's stacking engine aligns or registers each image with the reference. But in the example we just did, we removed the check marks from this box so that we could see that movement. But why does RSpec have to correct for star movement at all? Where does that movement come from? Why is the star moving from image to image? Well, of course, that's caused by our mount not perfectly tracking the star as it moves overhead. Oh, and by the way, when RSpec stacks images, any small star movements that come from bad astronomical seeing are also eliminated. These movements are caused by the air mass above your telescope, causing the star to wiggle back and forth in place. I'm going to do a screen capture of this smeared stack so that we can come back to it again in a moment. Okay, we're on to part 2 of the video. Let's drag the stacking options into view again, and I'll click Reset to Defaults. We can see that the default is also to have a check mark next to this Move ROI to keep target centered. Let's see how this checkbox works and why it's the default. If your telescope tracking isn't very good, your zero-order star, or any spectral feature that you might be using with the measure lines, for example, is going to move to a new location from frame to frame. We know that. As long as it doesn't move very far and stays inside the red capture box, there's no problem, because RSpec will align or register the star with your reference image with no problem. But sometimes, over a series of images, the star can accumulate a long distance, like it did here, where it drifted to a location that's completely outside the original red capture box. To avoid that, this checkmark tells RSpec that on each image, RSpec should nudge the red capture box so that once again the star is centered in it. Let's use a short animation here. Here's your first image, and the user drew the red capture box so the star is approximately in the center. And now let's look at the second image. See how the star moved because the telescope didn't track so well? So when the Move ROI checkbox has a check mark, RSpec repositions the red capture box so that the star is once again centered. And on the next, and the next, and the next. So even if the star moves a long way, it remains in the capture box. We wouldn't do this in normal day-to-day use, but let's see what happens if I remove the check mark from the Move ROI option. By unchecking this box, we'll see what would happen if RSpec doesn't move the red capture box to follow the star. We'll leave this default check mark on Align Images, so RSpec will attempt to align or register any images that the star is inside the capture box. So let's click the Stack button again. Here's our stacking result, and here's the previous one. In the new stack, the star started out in the same place as in our first example, and then, like the previous stack, it moved right and then up, ending in the same place. The star follows the same path, starting and stopping at the same point. But see how the current stacking run? RSpec was able to stack the first bunch of images into a nice star. That's because in the initial images, the star was still in the red capture box. So RSpec was able to find the star and use it to align the image with the reference image. But when the star drifted outside the red capture box here, the stacking engine couldn't find it, so these images out here aren't stacked at all. But in our previous image over here, since we turned off all registration or alignment, the star was always moving between images, so there was no bright star image anywhere, just a continuous smear. So listen, let's step back for a moment. You don't need to follow everything that I'm showing here. The main thing for you to understand is that the default for these two boxes is to have check marks. With those checked, RSpec does all the work for you. You know, at this point, some educators would say to me, Tom, you're going to lose your audience by including too many details in this video. And frankly, that worries me. The main thing I want you to take away from this video is to use the defaults. And hopefully, after watching this video, you'll have a better understanding of what a stacking engine does and how to handle the results. So, I'm going to close the stacking options screen. There's one more easy screen I want to show you in this video, and honestly, this segment probably has the most valuable day-to-day hint of this entire video. I'll start by popping up the plot screen. Now, there are a couple changes to this screen since the previous videos that you've watched. The y-axis used to be labeled ROI fit, but now it's called Similarity to Reference ROI. And yes, that's quite a mouthful to say, isn't it? But it more clearly describes what this axis represents. I've got a check mark down here so that we're just looking at that one axis on the graph. And in the videos I made earlier that you've watched, this label down here said to hold down the control key to click and open an image. But after I recorded those videos, I made a last-minute change to RSpec, removing the need to hold down the control key. I think it's a lot easier to use now. You just click. So I'm going to zoom into this region with my mouse wheel. If I hover over the highest point, that's our reference image at 100. If I click on it, the grid moves to that new row here, and of course the image opens in the usual spot. In this region of the graph, all the points are about the same value and they don't jump around too much. That's a good sign that everything's working well. So I'm going to double click to zoom out, and then I'm going to click through this plateau while you watch the star move to the right. The star is completely inside the red capture box still, so the ROI fit is still constant. As we expected, the capture box isn't following the star because remember, we're only aligning. We removed the checkbox from here, so RSpec isn't moving the red capture box to keep up with the star. So we're now standing at the top of the cliff. I'm going to head down the steep hill. Keep watching the star as it slowly leaves the red capture box. And by the way, I could use the Control-N key here also, but I find it a little easier to click in this situation. Here we go. Keep watching the star. See how the star is now about halfway out of the red capture box? And now we have another flat plateau. Remember, this axis shows how close the star matches the reference star. And now that our current image's star is about halfway out of the capture box, it's not a very good match. That's why these numbers go down. We can continue to advance to newer images. At this point, the fit quality drops way off and it starts jumping all over the place. The star has left the building. We're not tracking anything but noise right now. So hopefully, this little demo has given you a better idea about what the graph means and how to work with it. I want to emphasize again that for this video, we're covering a lot of background detail that in day-to-day use we seldom encounter. Why not? Because in normal use, we keep this box checked so the red capture box follows the star. The reason I wanted to show you this plot before we ended is that I wanted to help you understand that when you see the plot values plunge or they bounce around a lot, that means that you've either lost the star due to tracking problems, perhaps the star jumped a long distance completely out of the red capture box in a single frame, or, of course, if clouds or fog suddenly roll in, they can change the seeing conditions and the quality can degrade from that. Here's a hint for you, by the way. If you have this kind of tracking problem, or maybe you're seeing the ghost spectra we saw earlier, try drawing your capture box a bit larger. Or choose a different star or spectrum feature for the red capture box or measure lines. And maybe you need to work on improving your mount stability or tracking or guiding or polar alignment. You know, I'd be remiss if after all this I didn't show you the result when we stack this simple Aquari image with the default settings. So let's add a check mark and stack. Well, we've got a nice steady ROI fit here, right? And the red curve here, the stacked data, is much less noisy compared to the reference image in blue. So I have a special last-minute bonus animation for you. The video that's playing now shows all of the individual sub-images after they've been registered. The star isn't moving across the frame because the stacking engine aligned them all to the reference image's star. No, this video doesn't really help us with our stacking, but I wanted to share it with you because I think it's fascinating to watch and it's beautiful. Hopefully your star images will be more compact, less textured, less blurry, and your seeing will be more stable. And this brings us to a final important point. Stacking can't magically improve poor images. Sure, we've seen how stacking can remove a lot of noise, almost magically. But if your initial images are boiling and bubbling like we see in this animation, then stacking them isn't going to magically correct for that. So even if you plan to stack your images, make sure you do everything you can to make sure they're good images with good focus, good exposure times, etc. So if you're wondering how I made this animation, I added a check mark to these two check boxes. Then I stacked, and then I took all the images that checking these check boxes produced and turned them into a video using RSpec's Create Video and Preview Images menu. So you can breathe a sigh of relief because I'm not going to go through those steps here. So this video really is over now. And as I mentioned, the important takeaways are 1, use the Reset to Defaults button in day-to-day use. And 2, if the plot graph shows deep crashes and wildly varying values, there's a tracking problem.